Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Director of the University of Arizona Space Institute, and this is Arizona Science. Joining me today is Chris Walker, a professor of astronomy at the University of Arizona and the principal investigator of the student-built CatSat CubeSat mission, which is scheduled to launch soon. Welcome, Chris.
Hey, Tim.
Chris, we're used to thinking of spacecraft as being fairly big things launched on massive rockets, but CubeSats aren't made from that mold, right?
That's correct.
So tell me, how big is CatSat?
Well, the basic building block of a CubeSat is 10 by 10 by 10 centimeter cubes. And a CubeSat can be anything from 1U to 12 U's in size. You just put them together like Legos.
And a U is the 10 by 10 by 10.
The U is a 10 by 10 by 10 centimeters. That's absolutely correct. CatSat is a 6U CubeSat. So it'll be 20 by 30 by 10 centimeters, like a giant family-size cereal box.
Student involvement is one of the goals of the CubeSat missions, but there's usually a science or technology goal as well. What is CatSat designed to do?
Yeah, so CatSat actually has two science instruments on board and a technology demonstration instrument. So the technology demonstration instrument, which enables many aspects of the mission, is an inflatable half-meter spherical reflector. And that unit was donated by Freefall Aerospace here in town. The other instrument it has on it is an instrument that records ham radio signals that are emitted from the ground. It's thousands of them. And I'm one. I have one of these things at home as well that sends out these little beacons at low frequencies. And what CatSat's going to do is listen for them as it passes overhead. And on board, there is a software-defined radio called an SDR, which was donated by Rincon Research Incorporated here in town, that gathers these signals up, and then every couple of passes, it will downlink them through this half-meter antenna to Biosphere 6.1 meter antenna, which is a new thing out there at the Biosphere is worth seeing. So that's how the basic system works.
There are a lot of students working on this mission. How many?
Oh, good question. I mean, we originally proposed CatSat to NASA back in December of 2018. So it's been, how many years is it now? 4 years or so to put it together. And so we've had sort of generations of students. And so probably around 40 students over the years have been working on it. And we have a current cadre of students is about 10. And they're very motivated students, excellent students. And they're from all different departments in the university, different levels. We have them from aerospace engineering, of course. We have them from system and industrial engineering. We have PhD students in electrical engineering, aerospace mechanical engineering, undergrads from optical sciences, you name it, they're on board.
How do you deal with the transition since students graduate and move on?
Well, they help each other out. Now, students know when they're going to graduate. And so as the new students come in, the older students serve as mentors for the younger ones. So we have this continuous thread through the project.
So tell me a little bit about the launch. Are you going to be launching on a big rocket or something smaller?
It's going to be launching on nominally on a Firefly Black Alpha rocket, which is a new rocket by a private company who's had a couple of flights already. And the plan is the satellite, CatSat, was completed by the students just before the holidays, and they completed their testing of it and everything. It worked out well. And they will be delivered to Vandenberg Air Force Base within the next month or so. And then the actual launch will depend on what NASA wants to do, but nominally it's later this spring. NASA has a great program called the CubeSat Launch Initiative Program, CSLI program, and that's the program to which CatSat was proposed. And so under this program, NASA selects and pays for the launch of student satellites and other satellites as well. And this is one of them. The funding for CatSat actually came from the University of Arizona itself, from the Vice President of Research Office, and more recently from the University of Arizona Space Institute, along with generous donations from both Rincon Research and Freefall Aerospace.
How long will the mission be up?
It depends on the final orbit, but it could be up for several years.
Well, thanks for talking with us, Chris, and good luck with the mission.
Thank you.
This is Tim Swindle, and you have been listening to Arizona Science. Our guest today has been Chris Walker, who is overseeing the students building the CatSat CubeSat mission. You can also listen to this and other Arizona Science segments by going to the Arizona Public Media website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.